It's episode 14 of the Adam Ragusea podcast, catchable anywhere you catch pod, you podcatcher you, and today I, internet cook Adam Ragusea, I am going to address the very topic that people have been asking me to address for years now. The internet dietary health panic du jour, industrial seed oils. Already, that was not neutral framing on my part, I will acknowledge. A panic is a kind of irrational groupthink response, and by calling the industrial seed oil thing a panic, I am already biasing you, or at least I am revealing my bias. And yes, I think the current state of concern about polyunsaturated oils, derived chiefly from seeds, is, to a great extent, hysteria. Actually, that's not my opinion. That is the dominant scientific opinion, and I am simply deferring to it, as I should, being that I am neither a scientist nor a physician. I am a nerd who eats and reads a lot, often at the same time. Lots of grease prints on my laptop. If you follow the industrial seed oil panic on the internet, particularly on TikTok, you know that it has become almost an article of faith among so-called wellness influencers that refined oils derived from seeds are the chief culprit responsible for obesity and diabetes and heart disease and potentially even cancer and all the aspects of metabolic syndrome plaguing the residents of developed countries these days where we have access to more food than we need to survive. There is real science underlying some of these damning claims about seed oils. That doesn't mean the science is right, but the anti-seed oil crowd has real scientific literature that they can point to support some of their claims. And we are going to get into that literature in some detail in this podcast episode. But the overwhelming majority scientific opinion remains that you and I would probably be healthier if we replaced more of the saturated fats in our diet, say from animal products, if we replaced some of those with unsaturated fats derived mostly from plants, and one source of those would be industrial seed oils. So, first today we're going to do some definitions, explain what these core terms mean, like polyunsaturated fat. Then I'm going to talk about the panic and why I regard it as a panic. And then I'm going to try to take you inside the actual scientific debate about this stuff, the actual back and forth going on between actual scientists in the pages of actual nutrition journals. Scholarly publications that pretty much only scholars read. That's where the actual battle is being fought. That is where the outcome will be decided. And I'm going to show you in some detail a recent example of a scholar writing something in the scientific literature claiming that polyunsaturated fats are the worst. And then I'll show you a whole bunch of other scientists sweeping in and explaining, dude, like that's probably not really the case. Seed oils are probably really good for people within reason. The notion that seed oils are responsible for almost all the bad things, this is a fringe theory for a reason, is probably wrong based on the available evidence. Which is to say, new evidence might prove it to be right, but that hasn't happened yet. So first, definitions. Saturated versus unsaturated fat. Fats have these long carbon chains on them. Each carbon atom has 4 bonding sites. That is true of carbon generally. In saturated fat, each carbon has a single bond to the carbon to its left and a single bond to the carbon to its right in the line, in the chain. So that's 2 bonds out of the 4 occupied, just holding hands with its little neighbors. The other 2 bonds are occupied by hydrogen atoms, as is generally the case in organic chemistry. In organic chemistry, carbon is everywhere. That's why they don't even bother labeling the carbon on the skeletal structural diagrams that you may have seen in my videos, among other places. And if there's an unlabeled point on one of those diagrams, it's carbon. And it is generally true in organic chemistry that where there is carbon, there is hydrogen stuck to it. So in those diagrams, you are to assume that any available bonding sites on the carbons are occupied with hydrogen, because usually they are occupied with hydrogen, as is in the case with fats. So, saturated fat, like the kind we get heavily from animal fats, saturated fat is saturated with hydrogen atoms. That's what that means. Saturated with hydrogen. The carbon chain is holding the maximum number of hydrogens it can hold, which is 2 on every carbon, except for the one at the very end, which has 3. In unsaturated fat, some of the carbons have double bonds to each other, meaning instead of one bonding site connecting the carbon to its neighbor on the left or whatever, they have 2 bonds between them. 2 carbons holding hands with 2 arms each. In this metaphor, carbons have 4 arms, of course, so the third arm is holding on to its other carbon neighbor, the one on the right in the chain, and the fourth arm, the only remaining available arm, is holding on to a hydrogen, a single hydrogen on that carbon, instead of the 2 hydrogens we see in a carbon in a chain of saturated fat. Fewer hydrogens than the maximum means unsaturated with hydrogen. So, a monounsaturated fat like olive oil is saturated except for just one of the carbon bonds. One of the carbon bonds is a double bond. And as a result, those 2 carbon atoms joined by that one double bond, those 2 carbon atoms have fewer bonding sites available for hydrogen. So it's not carrying the maximum amount of hydrogen, which is why we say it's unsaturated, monounsaturated. Polyunsaturated fat, like most of the oil we get from seeds, polyunsaturated fats have more than one double bond. So they're holding on to a lot less hydrogen than they theoretically could. They have multiple double carbon bonds, so they have fewer bonds available for hydrogen. And it gets way more complicated than that. There are lots of subcategories within the categories of saturated and monounsaturated and polyunsaturated. There are trans and cis bonds. Yes, that's where we get the term cis in the world of gender identity terminology. It is imported from organic chemistry. Why does any of this chemistry matter in conversations about food and health? Well, because the unsaturated fats are less stable. Unsaturated fats are more vulnerable to being broken apart or otherwise changed by outside forces, by enzymes, by water, by microbes, by light, by oxygen. Those double carbon bonds in the unsaturated fats are easily broken, thus exposing bonding sites that can react with other things like oxygen. This can create off flavors in food. Rancidity is a kind of oxidation of unsaturated fatty acids. Animal fats are usually very high in saturated fats. Plant oils usually are not. And indeed, that's one reason we call beef fat fat, and we call olive oil oil. By one definition, fat is a lipid that's solid at room temperature, and oil is one that's liquid at room temperature. The more saturated fatty acids you have in the mix, the more likely it is to be solid at room temperature. That's why a jar of lard is solid until you melt it in a hot pan. That's one reason why the processed food industry loves saturated fats. You can use them to make prepackaged cookies and cakes and such that are full of delicious, shelf-stable fat, and yet they are still solid. Another reason they like saturated fats is saturated fats are more stable, as we just said. They're less likely to react with oxygen and to oxidize. Processed food manufacturers want to make products that will last at room temperature, wrapped in plastic, for months or even years. They like to fill their products with fat because fat is delicious, and fat is a source of moist texture that is not hospitable to microbial life, unlike water. If you can make a cake that derives nearly all of its moist texture from fat instead of water, it is very unlikely that any mold or other microorganism will be able to thrive in there and spoil the product. And if you use saturated fat, the cake won't go rancid. Animal fats are highly saturated, usually, but animal fats are expensive. And some people are grossed out by the idea of cakes made with lard or French fries fried in beef tallow. Plus, animal fats tend to also be very high in cholesterol. And in the mid to late 20th century, it was widely believed that rising rates of heart disease and stroke and such were significantly attributable to dietary cholesterol. That turned out to not really be the case because your body makes cholesterol whether you eat cholesterol or not. That's what we talked about in last week's episode. Listen to it if you've not already. But all of that is part of the milieu in which so-called industrial seed oils exploded in use in the late 20th century. Humans, of course, had been getting oils from seeds for thousands of years before that. First by simply eating seeds. Most human food is seeds. Grains are seeds, beans are seeds, nuts are seeds, peas, green beans, corn. I guess I already said that because corn is a grain, but think of all of the grains and flours and breads we make out of them. Rice, it's all seeds. Seeds usually have a fair bit of fat in them to help the resulting baby plant get growing. So since the hunter-gatherer days, we humans have been gathering up wild seeds of various kinds and eating them, including their delicious, nourishing oils contained therein. At some point along the line, we started farming seeds instead of just gathering up wild ones, and at some point along the line, we started crushing the seeds to juice the oils out of them. This is an ancient practice. About 5,000 years ago, they started pressing oil from soybeans in East Asia. In South Asia, they pressed it from sesame seeds, and they exported that practice to the Middle East. Most of the oils we get from plants are from seeds. It's become hip for people to say, hey, dude, there's no such thing as vegetable oil. It's seed oil. Well, no shit, Sherlock. Vegetable is not a scientific term. Historically, vegetable just meant plant matter of any kind. Only recently has the word acquired a more narrow meaning than that. And if you want to quibble about it, olive oil and palm oil don't fit with the contemporary definition of vegetable either, because those are fruits, not vegetables. They're fruits with seeds inside. And we get oil from the fruit and from the seed. Palm seed oil, or palm kernel oil it's called, is notable because it's mostly saturated, even though it's a plant oil and not an animal fat. But anyway, we get most of our plant oil from seeds because seeds have a lot of oil. And because seeds are sometimes not that good for anything else. You've seen canola oil. Have you ever seen a canola? No? That's because they suck. They're also called rape seeds, which is fittingly not an appetizing name. Rapeseed comes from a brassica, like broccoli and cabbage. It is also ancient, cultivated in India 4,000 years ago. But it naturally has this stuff in it called erucic acid, which in large quantities will damage the heart muscle of animals, such as ourselves and our livestock that we're feeding, so that is bad. So canola oil wasn't really useful until the 1970s, when a couple of scientists at the University of Manitoba in Canada developed rape seeds with a lot less erucic acid. There were similar innovations being made around the same time with other oil seed crops, different ways of breeding them, new ways of farming them, new ways of extracting their oils. Pressing works, but it's not super efficient. You don't get all the oil out. Pressing with heat is more efficient. You get more oil out, but it changes the product, the heat does. It degrades the quality in some ways. Science delivered a super efficient means of extraction in the form of solvents, chemicals you mix in with the seeds to break them down and extract the oil, make it separate out. A common solvent used for this is hexane, used for canola oil and soybean oil. Hexane is nasty stuff derived from crude oil. As anti-seed oil wellness influencers will be super excited to tell you about in breathless terms, but just because a chemical is used to produce a product doesn't mean the chemical remains in the product in any meaningful quantity. They use the hexane to break down the oil, then they get the hexane out. Now, some serious people are concerned about trace hexane in foods and whether it's regulated tightly enough. And sure, there's lots of other kind of unwholesome processes used to extract and refine seed oils. That's the industrial part in the industrial seed oil epithet. Lots of these oils taste real funky in their natural state, so they use chemical and physical processes to get some of those weird tastes out. Lots of the oils are particularly unstable, so they process them to make the oils more stable, less likely to go rancid. A lot of these refining processes sound pretty exotic and therefore scary and unappetizing, but that doesn't mean they're actually bad. Some of them may indeed be bad in certain ways. And again, serious people have actual human health concerns about all kinds of the food oil refining processes used. But that's not the main scientific argument against seed oils. The main scientific argument against seed oils is that they are mostly polyunsaturated fats. Fats that have multiple double carbon bonds. Ironically, the fact that they are mostly polyunsaturated fats is also the primary scientific argument in favor of eating seed oils. The overwhelming majority scientific opinion is that polyunsaturated fats, within reason, are good for you, and that most of us would be healthier if we replaced some of the saturated fat in our diet with polyunsaturated fat. And basically everyone agrees that monounsaturated fat is good for you, within reason, which is one of the many reasons I use extra virgin olive oil for basically everything, but we'll come back to that. Why have people gone completely apeshit about seed oils lately? Well, in part, it's because there is a real minority scientific opinion that polyunsaturated fats are actually terrible for you. And we'll get into the nitty-gritty of that in a moment. Just remember for now that it is a minority fringe opinion. I think, and this is just me spitballing, speculating now, I think there are a few cultural reasons why people in the general public were and are really receptive to the idea that seed oils are actually evil. For one thing, we are always receptive to the idea that obesity and type 2 diabetes and all the other plagues of developed countries that have too much food, we are receptive to the idea that those are actually caused by this one thing: gluten, sugar, seed oils. And if we could just cut that one thing, then we can go on eating way too much food and getting not nearly enough exercise, and everything will be fine. Fact of the matter is, per capita calorie consumption has exploded in recent decades in the developed world. And at the same time, our lifestyles have become far more sedentary. Fewer of us do manual labor. Those of us in car-centric countries hardly walk anywhere anymore because we can't, because our built environment makes walking untenable, useless at best and dangerous at worst. I think it's fair to say that the majority scientific opinion is that industrial seed oil, this actually is responsible for the metabolic syndrome epidemic, in as much as seed oils represent yet another highly refined source of concentrated calories that we can jam into shelf-stable products and buy anywhere for not that much money and gorge. It's appealing, the notion that the problem is the kind of oil we're eating, and not, our whole damn lifestyle. Here I'm going to get into some more controversial territory. I think the seed oil panic is intertwined with a crisis of masculinity in developed countries. Male-identifying people, we have seen our world change real fast in recent decades in ways that undermine our historic sources of prestige and power. Fewer of us work manual jobs where our strength was an advantage. The women in our lives are more powerful and less subject to our historic domination of them. And the world is less violent, especially the developed world. We can't obtain prestige through combat as easily as we once could. All of this has led to a wave of male revanchism. Dudes who want to reclaim what they perceive as their lost glory. And if you look in the corners of the internet where these men talk to each other, a lot of them are real freaked out about industrial seed oils. There is a subtext in these forums, and occasionally it's a text, that seeds are for birds, and birds are effeminate, dainty little creatures. Real men eat meat, because meat is a product of violence, the hunt. I, Adam Ragusea, I am a meat eater, but even I can acknowledge that even the most humane slaughter is still, by definition, an act of violence. And certainly, historically, hunting has been a proxy for war, or a way of practicing for war, or an echo of war, I once heard a historian put it. Warrior aristocracies would often obtain their power through war, and then they would hunt avidly for the rest of their lives, and for several generations after, to use these war skills that got them into their positions of power and wealth. Echo of war. Conquest. For decades, scientists and doctors have been telling us to reduce our saturated fat. And that mostly means eating less meat and other animal products. Less beef. Now some fringe scientist comes along and says, hey, actually, it's the bird food that's making you fat and weak. You got to go back to the beef. That's an appealing argument to anyone who likes beef, including me. And it's especially appealing to dudes whose fragile masculinity is under threat, real or perceived. I just hope those dudes know that most of the food they eat is seeds. The bun on the hamburger is baked seed paste. Anyway. Certainly people who lack power and prestige are particularly excited to embrace all kinds of minority opinions that fly in the face of established wisdom. If you're not part of the power structure, if you're not in the know, if you don't know anything, well, a very quick and very easy way to feel like actually you're the smart one is to believe some fringe theory that comes along. Then you can say to yourself, aha, actually I know, and you don't know. And the reason you think I don't know anything is because what I know is a threat to you. Because what you think you know is different from what I know I know. Because that guy over there told me about it. And if you believe that seed oil is the root of most dietary evil, you can very easily confirm that belief through lived experience. The internet is full of stories of people who cut out seed oils, and within months, they're shredded and they feel great. But you'll find stories like that from people who cut out carbs or cut out gluten. Why? Well, there's probably lots of reasons on a case-by-case basis, but the most common one, most likely, is that if you cut out refined oils or refined carbs or gluten, you're going to end up cutting out most junk food. Cut out just one of those things, and it will instantly become very hard for you to eat any super refined calorie bomb that's totally lacking in fiber and potentially lacking in vitamins and minerals. If you cut out refined oils, you're going to be pushed into eating whole foods by default. Not Whole Foods, the grocery chain, but actual whole foods. Whole grains, whole fruits, whole vegetables, the calories plus the fiber that they're naturally packaged in. We talked extensively in the last episode about why fiber is so great and how we ended up not eating nearly enough of it in developed countries. So sure, I'm about to go deep into the science of why polyunsaturated fats probably aren't the devil. But I'll admit right now that oils of all kinds are probably not the best thing in my diet because they are concentrated calorie slicks and I eat too many calories. I eat oils anyway. There are all kinds of things I consume, even though they might not be the most healthful things for me to consume. I consume them nonetheless because life is about making choices and balancing competing interests. Refined polyunsaturated fats taste good in certain contexts, and there are other things that you could consume instead that are far worse for your health, based on the preponderance of available evidence. And I endeavor to consume them in moderate quantities that are unlikely to harm me in any significant extent. I do this with all kinds of things, not just oils. I do it with alcohol, for example. These days, I think my relationship with alcohol is actually quite healthy. And a drink that I have been enjoying very much lately is sake from Tipsy, the sponsor of this episode. Let me thank them for a moment before we move on. Sake, of course, is the delicious traditional rice wine of East Asia. And Tipsy is the largest sake online store in the United States, carrying more than 400 labels, such as this super dry Asian beauty bottle that I've been enjoying. Tipsy's whole thing is that they want to make sake approachable. Each product page online decodes all of the difficult sake terms of art for you, and it recommends food pairings and serving temperatures. The uninitiated may only know sake as a hot drink, and hot sake certainly can be a lovely winter treat, but there's all kinds of sake that are really better chilled, like this one, chilled to varying degrees. I've been loving sake in the summer, this crazy hot summer. Delicious. There's a Tipsy Sake Club where you can receive a special curated box every 3 months. I've got mine right here. Each box comes with 6 of these little bottles, 10 ounces. So you can try a lot of different things without overdoing it. You get Tipsy's guide for sake beginners. You get unlimited free shipping for regular orders. You get virtual tasting videos for each featured sake, all kinds of fun stuff. Follow my link that is in the show notes or in the video description if you're watching this on YouTube. It's tipsysake.com/discount/Adam. tipsysake.com/discount/Adam. I've got 2 different discount codes to tell you about. Use code ADAM for 10% off all products, and use code ADAM30 for $30 off your first big sake box like the one that I have. Code ADAM for 10% off everything, ADAM30 for $30 off your box. Ken Pie. Thank you, Tipsy. So, the science of polyunsaturated fats. By way of example, I'm going to walk us through a very recent scientific exchange. A paper from 2021 asserting that unsaturated fats may actually be worse than saturated fats. And then we're going to go through a couple of responses in the same journal to that paper. Other scientists saying, no, you're looking at the data wrong, dude. And then we're going to look at the original author's response to the responses. So, in the Journal of Advances in Nutrition, May 2021, we see a paper by Dr. Glenn D. Lawrence, professor of chemistry and biochemistry at Long Island University, Brooklyn. Dr. Lawrence is a serious scientist with what looks to be a pretty conventional scholarly background. He's an older guy. He's been around a long time. He's not some kid. He's put out a book in 2019 that was for a general audience, a popular science book. It was called The Low-Fat Lie: Rise of Obesity, Diabetes, and Inflammation. And in this book, he argues that the late 20th century war on dietary fat made everybody fatter and sicker because people replaced fats with carbs, including sugar, and sugar turned out to be worse for us than the fats. That is not a terribly controversial opinion. In fact, I believe that is the majority scientific opinion now. Low-fat, high-carb is not the way to go, unless you're really disciplined and you keep it to complex carbs and whole grains and very little sugar. And most people are not that disciplined. Also, in his 2019 book for the general public, Dr. Lawrence argues that the dominant dietary advice to replace saturated fats with unsaturated plant oils, he argues that this has also done more harm than good, contributing to chronic inflammation and diabetes and heart disease and even cancer. That is a controversial opinion. That is an opinion that flies in the face of the clear majority scientific opinion. That doesn't mean he's wrong. Minority opinions often blossom into majority opinions. But I will say that as an unschooled consumer of nutrition science, that's me, I am skeptical of scholars who hold serious outlier scientific opinions and who choose to bring those opinions to the public before they get at least a significant minority of their scientific peers on board with them. The public is easy to convince. We do not have the tools to effectively scrutinize esoteric scientific claims. I've read parts of Dr. Lawrence's 2019 book, and they read very persuasively to me. But I am easily persuaded because I don't know what I'm talking about. I don't know what I'm talking about at this very high level of conversation that we're about to dip our toes into. It's much harder to persuade one's scholarly peers. And Dr. Lawrence has, as far as I can see, failed to do that on any significant scale. So when a scientist fails to persuade the other experts, and then turns around and tries the same arguments out on the non-experts, that to me is a flag of some kind. I won't call it a red flag. That's too strong a word. Let's call it a pink flag. Sometimes the scientific establishment is wrong. It is often wrong. And sometimes you get a Jeremiah-like figure who sees the truth before anyone else does, and none of the other priests and the prophets will listen. So this scientific Jeremiah has no choice but to weep and harangue on the steps of the temple in hopes that someone, anyone, will hear the truth. People like that exist in the history of science. People who turned out to be right. But those people are in the minority compared to the much larger group of false prophets who scream and harangue that they're right and everybody else is wrong. And in the fullness of time, it turns out that these minority scientific views were in the minority for a reason, because they were wrong. So, I don't wholly discredit apostate scientists who write books for the general public, taking their case to the general public because they failed in the scientific establishment. But when they do that, it does make me raise one corner of one eyebrow. It's a pink flag to me. Anyway, Dr. Glenn D. Lawrence, to his credit, is trying to persuade his scientific peers that replacing saturated fats with polyunsaturated fats might do more harm than good. He's trying to convince his peers of that, which brings us back to his 2021 piece in the journal Advances in Nutrition from the American Society for Nutrition, which is a mainstream professional society criticized for its ties to industry, as basically all professional associations are, probably rightly. Anyway, Dr. Lawrence's piece appears in the Perspectives section of the journal, which means it's not a study. It does not purport to be original research or meta-analysis or anything like that. Such pieces are basically high-grade op-eds. They are very in-depth, esoteric opinion pieces by scholars who are making an argument to other scholars. Such pieces are generally peer-reviewed and exhaustively sourced, so we're not talking about a big meta-analysis here or an original study, but we're still talking about a serious work of scholarship, not a newspaper opinion piece, not a Reddit post. This is the real shit. This is a scholar trying to persuade his peers in a conversation that is available to the rest of us, but it doesn't really involve us, and it is not intended to be accessible to us. It's not for us. So keep all that in mind. The title of Dr. Lawrence's perspective is The Saturated Fat Unsaturated Oil Dilemma: Relations of Dietary Fatty Acids and Serum Cholesterol, Atherosclerosis, Inflammation, Cancer, and All-Cause Mortality. Lawrence argues that the available studies indicate saturated fats are not the big cause of high cholesterol. He says scientists got that idea by doing studies where they changed up the types of fats in people's diets, and people who lowered saturated fats lowered their cholesterol. That indeed happened. But Dr. Lawrence argues the cause was not that they lowered their saturated fats, but rather the cause was that they increased their polyunsaturated fats to compensate for the decrease in saturated fats. Quote, "Polyunsaturated fats are known to regulate cholesterol synthesis and cellular uptake by multiple mechanisms that do not involve saturated fats." So, in other words, when you eat polyunsaturated fats, like the kinds you'll find in industrial seed oils, your body makes less cholesterol in response. And that's a thing that polyunsaturated fat does all by itself. So, when people cut their saturated fats and increase their polyunsaturated fats, the reason their cholesterol goes down is not the fact that they're eating less saturated fats, is that they're eating more polyunsaturated fat. This is Dr. Lawrence's argument, and some of it is not controversial. Some of it is. We'll get to that. Anyway, you can prove this, Dr. Lawrence argues, by looking at people who replace some of the saturated fats in their diet with carbs, and they leave their polyunsaturated fat intake unchanged. Those people show no change in their blood cholesterol. So the saturated fat can't be the causal factor. And what's worse, Dr. Lawrence says, people who swap saturated fats for carbs show an increase in lipid fractions, which is parts of fats in the blood, in lipid fractions that are likely to cause type 2 diabetes and metabolic syndrome. It's not just about atherosclerosis and heart attacks and strokes, Dr. Lawrence argues. He says we should consider overall mortality when making dietary recommendations. If a diet lowers your odds of dying by heart attack, but raises your odds of dying from diabetes by a higher degree, well, that's a bad diet. We should not worry about blood cholesterol to the exclusion of other worries. Lawrence points to studies that show old people with very low cholesterol are actually more likely to die of something in a given study period than old people with intermediate or even moderately high cholesterol. That's a pretty compelling finding, IMHO, but we'll come back to it. Lawrence goes on to argue that even if polyunsaturated fats do lower cholesterol, that doesn't mean they're better for you. Of course, polyunsaturated fats are essential nutrients. We have to consume some of them, and Lawrence acknowledges that, but he says an excess of polyunsaturated fats may become toxic. And those risks outweigh the benefits of lowering your cholesterol. Polyunsaturated fats oxidize in the bottle, in the pan, in the food, and in the body. Quote, toxic organic products formed during lipid peroxidation of polyunsaturated fats can cause mutations in DNA, which can lead to cancer. The quote continues, lipid peroxidation can damage cell membranes and lead to cell death. End quote. Furthermore, Lawrence says that while polyunsaturated fats may lower your total cholesterol and even lower your LDL or bad cholesterol, the specific kind of fatty acids contributed to your LDL by polyunsaturated fats, well, those are more prone to oxidize and actually form deposits in your arteries, plaque, blockages, atherosclerosis. So, even if polyunsaturated fats lower your cholesterol, they may actually increase the odds of the cholesterol that you do have forming actual blockages. And those blockages are the actual problem with cholesterol. In contrast, monounsaturated fats like olive oil are relatively resistant to oxidation, and saturated fats are wholly resistant to oxidation. The goal, Dr. Lawrence argues, should be to keep people alive and healthy, not to lower their cholesterol. And, Dr. Lawrence argues, an excess of polyunsaturated fats are bad for your longevity and health for other reasons. He says they cause chronic systemic inflammation, which leads to type 2 diabetes and metabolic syndrome. Omega-6 fatty acids in particular, which are a kind of polyunsaturated fat, he says they initiate inflammation in the body as a kind of immune system response. For example, omega-6s are metabolized in the body into arachidonic acid, which is a building block of lipids that initiate inflammatory response in the body. And these effects persist for some time, even after you stop eating so many omega-6s, because the resulting metabolites stick around in your cell walls and in your body fat, your adipose tissue. Lawrence concludes, quote, when looking at much of the data in the context of known biochemical and physiological mechanisms, it appears that saturated fats are less harmful than the common alternatives. End quote. Now, I have massively simplified what Dr. Lawrence wrote. One, because I'm trying to keep this reasonably tight, and two, because I do not understand much of what he wrote. I am not a scientist or a physician. But let's look at the responses from people who are. The journal published 2 letters to the editor written in response to Dr. Lawrence's paper. The first is from 3 authors, Dr. Martha Belluri at Ohio State, Dr. Emilio Loss at University of Barcelona, and Dr. Penny Chris Etherton at my alma mater, Penn State. I'll try not to show her favor on that basis. These three scientists write, quote, "The article by Lawrence has many inaccuracies and ignores the overwhelming literature that strongly demonstrates health benefits of replacing dietary saturated fats with polyunsaturated fats." The quote continues, "A repeated theme of Lawrence's article is the selection of individual papers with interpretations that are often misleading and in some cases inaccurate." End quote. Belluri et al. Acknowledge that the late 20th century war on fat was bad. They agree with Lawrence. When you replace saturated fats with sugars and other refined carbohydrates, the result is increased obesity, type 2 diabetes, all kinds of bad things. But they argue that Lawrence was just wrong about a lot of the other stuff, like his claims that saturated fat does not raise cholesterol. They acknowledge that polyunsaturated fats do seem to lower cholesterol independent of saturated fat. So it's not just about saturated fat, but saturated fat does also seem to raise cholesterol all by itself. Quote, "An extensive meta-analysis of clinical studies showed that replacing saturated fats with dietary carbohydrate reduces total cholesterol and LDL cholesterol." End quote. So that would indicate that saturated fat does increase cholesterol independent of polyunsaturated fats in your diet, or the lack thereof. And Lawrence is simply misreading the data, or cherry-picking from individual studies while ignoring the totality of the evidence. Now remember, Lawrence argued that it's not all about blood cholesterol anyway. It's about whether that cholesterol actually becomes plaque in your arteries. And he argued that polyunsaturated fats oxidize and are more likely to actually become a blockage in your system, even if your cholesterol is lower. Now, what do the three replying scientists say to that? Quote, "Lawrence's section on polyunsaturated fat oxidation and inflammation is one-sided and oversimplifies an ever-expanding area of nutrition involving metabolomics, data analytics, physiology, endocrinology, and cell biology." End quote. So basically, Lawrence, in his paper, was making a mechanistic argument. He's saying, look, we can see from animal studies and from test tube studies that polyunsaturated fats do this thing in certain circumstances. And if they do that thing, well, that mechanism would predict a certain effect in actual human bodies. And what the replying authors are saying is, look, we're just only beginning to understand the mechanisms involved in this stuff, and you are leaping to conclusions. These mechanisms involve gene expression and all kinds of crazy stuff, and it's not as simple as you're making it sound, Dr. Lawrence. Now, remember the part about how omega-6s are metabolized into this acid, and this acid promotes inflammation, which leads to diabetes and all of that? Well, here's what the responding authors say to that. Quote, "Metabolites derived from polyunsaturated fats may induce acute inflammatory pathways, but also exert potential anti-inflammatory and pro-resolving activities in tissues. Inflammation that is modulated by oxylipins is not determined simply by polyunsaturated fats, but rather a complex milieu of cellular processes, including polyunsaturated fat content of membranes, energy availability in cells, and the short half-life of most oxylipins." End quote. The oxylipins they're talking about there are things made with the arachidonic acid, which is metabolized from omega-6s. So, quote, "Unfortunately, Lawrence failed to capture the state of the art of the consistent and evolving science showing the importance of polyunsaturated fats in maintaining and promoting health and the harmful outcomes of diets rich in saturated fats." End quote. Now, what about that thing where Lawrence said that old people with very low cholesterol are actually more likely to die than old people with moderate to moderately high cholesterol? Well, studies in Finland and Korea actually did show that. Lawrence used those studies to argue that the cholesterol-lowering properties of polyunsaturated fats are outweighed by all of the other bad things that excess polyunsaturated fats can do to us. Pretty persuasive, as I said before, but again, Lawrence is misreading the data. Says Dr. Jeff M. Moore of San Diego State University, who also has a published rebuttal to Lawrence's study in the Journal of Advances in Nutrition. Moore writes that those studies from Korea and Finland are, quote, confounded by reverse causality, end quote. Reverse causality is when you correctly identify a correlation between two things that are indeed correlated, but you're wrong about which thing is causing the other. So a common example from the food world would be diet soda. If you follow fitness influencers or whatever, like I do, how many times have you heard one of them say something like, "Oh man, don't drink diet soda. Only fat people drink diet soda." Well, yeah, because people choose diet soda because they feel a need to lower their calories because they're fat. It's not that the diet soda is making them fat, they're fat, so they choose diet soda. That science on diet soda is more complicated than that, and I'll do a whole thing about diet soda another day, but that's the basic concept of reverse causality. In the case of very low cholesterol being associated with elevated risk of death, there are other potential explanations than Lawrence's. Remember that Lawrence's explanation was polyunsaturated fats lower your cholesterol, but they also kill you in other ways. There are other explanations other than Lawrence's. Specifically, other scientists have documented a link between very low cholesterol and cancer. It's not that low cholesterol causes cancer, but rather that some as yet not understood mechanism is causing both cancer and low cholesterol. In fact, an otherwise unexplained drop in your cholesterol is now being used by physicians as an early warning sign of cancer. People's cholesterol seems to drop many years before their cancer would normally be diagnosed. So, what other scientists think is probably the case is that people are getting cancer, and whatever factor results in the cancer is, through some kind of metabolic pathway, also lowering their cholesterol. And thus, those people incidentally have low cholesterol when they die of cancer. But the low cholesterol didn't cause them to die of cancer. Maybe the oxidized polyunsaturated fat caused them to die of cancer, but other things could have done it too. And there's other confounding things in those studies. Those studies looked specifically at very old people. And very old people may be suffering from conditions that incidentally lower their cholesterol while also killing them. Slowly dying old people usually don't eat much or at all. They waste away. This lowers their cholesterol, and so they have lower cholesterol when they die of the thing that caused them to stop eating. So, how do you avoid reverse causality when analyzing data like this? Well, there's something called Mendelian randomization, where you use genetics to try to figure out which factor is causing which factor. I'm not going to go into it in detail now, mostly because I only halfway understand it, but look it up if you're interested. So Dr. Moore, in his reply to Dr. Lawrence, writes, quote, Mendelian randomization studies, a unique form of genetic epidemiology robust to reverse causality, show low serum cholesterol throughout life is associated with reduced morbidity and mortality. End quote. So this finding that low cholesterol is more deadly than moderately high cholesterol, that's likely a case of reverse causality People with low cholesterol are dying for other reasons. Dr. Moore is really far more brutal on Dr. Lawrence than the other three responding scientists we talked about, or at least it's more brutal to my reading. Regarding Lawrence's claim that replacing saturated fat with unsaturated fat increases inflammation, Moore says that those claims are based on animal studies and test tube studies, not studies on actual living humans, and they don't capture the whole picture. Yes, polyunsaturated fats have pro-inflammatory effects, but they also have anti-inflammatory effects. Quote, a systemic review of randomized clinical trials found no evidence of inflammation from polyunsaturated linoleic acid. That's omega-6. Resuming the quote. A 10-week randomized clinical trial comparing a high polyunsaturated fat diet with a high saturated fat diet found inflammatory markers to be lower with the polyunsaturated fat diet. End quote. So again, other scientists are coming in here to say that Lawrence is drawing conclusions based on how he thinks things would work in the human body, not on how they apparently actually do work when you look at real people in the wild. Same thing with Lawrence's claim that polyunsaturated fats are more likely to oxidize and form plaque in your arteries, even if they also lower your overall cholesterol. In response to that claim, Moore writes, quote, no evidence is provided. The author speculates from in vitro evidence and from animal models. End quote. In vitro evidence, that means test tube studies. Actual clinical trials with actual humans in the wild, those show that replacing saturated fats with polyunsaturated fats, that actually lowers your risk of atherosclerosis, plaque in the arteries. That's what Moore is saying. And Moore, like the other three authors, points out that one of Lawrence's claims is directly contradicted by the very study that he is citing. Lawrence cites this one 2005 study as evidence that swapping saturated fats for carbohydrates results in no change in blood cholesterol. The study Lawrence cites says the exact opposite of that. Now, the journal did what scholarly journals will often do in these situations, and it gave these rebuttal letters to Dr. Lawrence so that he could write a rebuttal to the rebuttals that would appear in the same issue, which he did. So let's look through that. Lawrence starts by repeating the correlation between very low cholesterol and death, and he asserts that the rebuttals failed to deal with or explain this correlation. Now I, Adam Ragusea, I am saying now that Lawrence is just wrong about that. Moore absolutely does deal with that correlation, and to my reading, dispenses with the relevance of that correlation. I don't know how Lawrence missed that. Lawrence starts weak, in my opinion, but then he builds up some steam. He says, yeah, of course, I'm relying very heavily on animal studies and on test tube studies to draw my conclusions that polyunsaturated fats are actually way worse for you than saturated fats. But that's because the observational studies of actual humans in the wild are inherently problematic. It's really hard to do those kinds of studies and accurately capture what real, free-living humans are really doing or not doing with their diet. And in general, Lawrence argues, the studies have not paid close enough attention to subtle differences in actual polyunsaturated fat intake and how those differences might affect people's health. And then Lawrence goes back on to quibble with other points made by the responders. For example, a study that Moore said looked at atherosclerosis didn't actually look at atherosclerosis. It actually just looked at cholesterol, which can cause atherosclerosis, but of course it's not a one-to-one correlation. I'm going to stop right now with the scientific he said, she said. Going to stop. I realize that I'm maybe giving Lawrence's rebuttal to the rebuttals short shrift, but this is getting super long, and we need to move on. You can read all of these papers and letters yourself. I have them linked in the show notes / description. What I have just laid out for you is one exchange between 5 scientists. That happened over the course of the last year. And it's a case of 4 against 1. 4 scientists arguing that polyunsaturated fats are good, 1 arguing that they are bad. That's an obscene oversimplification, but I'm going to need to do some oversimplifying now to stick the landing here in a timely manner. Bear with me. This is just one case. It's one case. But based on my pretty extensive reading of the scientific literature on this topic, this is a representative case. This is how these conversations usually go. Most serious scientific conversations on which the whole industrial seed oil panic is based, most of those conversations go like this. One person makes some claims that polyunsaturated fats are terrible, and then way more scientists swoop in and say, look, there may be some truth to what you're observing here, but we're learning more all the time, and you are leaping to conclusions that fly in the face of the overwhelming majority of evidence that we have available. The overwhelming scientific opinion remains when the average adult in a developed country replaces some of their saturated fat intake with polyunsaturated fats, seed oils, then those people get healthier. Why? We still don't fully understand, but it really does seem to be true. Now, there are people who have been listening to my entire podcast here, and they have been screaming in their heads this whole time, well, yeah, the scientists have been bought off by the seed oil lobby and the junk food manufacturers. Harvard and the American Heart Association, they are beholden to the polyunsaturated fat industrial complex that funds them. And to that, I say, maybe they are. It's happened before. In the 1960s, a sugar industry group paid Harvard scientists to produce research that blamed fats for America's rising heart disease problems. Blamed fats instead of sugars, because that would be bad for the sugar industry. This research contributed to the late 20th century war on fat that everyone now acknowledges was bad and did more harm than good. If you replace fats in your diet with sugar and highly refined carbs like white flour, your health will probably get worse, not better. Nobody disagrees about that now, as far as I can see. And that instance of the sugar industry buying off Harvard scientists in the 1960s, that's not like a Reddit conspiracy theory. This was documented in the Journal of the American Medical Association in 2016, with the cooperation of Harvard, it should be said. Science ain't perfect. I have said before, and I will say again, that I will not be surprised if the whole saturated fat bad, polyunsaturated fat good paradigm continues to get refined in the coming years, as scientists learn more, and perhaps some minority opinions become majority opinions. But I don't think the current prevailing view can be fully explained by the seed oil industry buying scientists. Why? Because a few reasons. Because first, the current prevailing view just involves so many scientists and so many papers, and I just don't think that big canola could buy them all. Second, there is also huge industry money behind saturated fats. Do you realize how powerful the beef lobby is in the United States in particular? The beef industry would love to prove that saturated fats are just fine, and that polyunsaturated fats are the real devil. Beef has a ton of saturated fat. They used to fry the fries at McDonald's in beef tallow, but they switched to seed oils because science said seed oils are better than beef fat. Saturated and unsaturated fats both have massively powerful industries behind them, and I reckon those forces cancel each other out to some extent. In a video that I made a couple of years ago on YouTube, I cited some then new studies that undermined the link between red meat and bad health outcomes. And at the time, some people criticized me for mentioning those studies because the authors of those studies turned out to have undisclosed beef industry ties via Texas A&M University. And fair enough. I didn't issue any kind of correction or anything because I did not cite those studies as being like the final word on the issue. I mentioned them as an example of how the science is always changing and the pendulum is swinging in one direction or the other, and gradually we inch closer and closer to the truth. This was my Why I Ride for Science video, if you want to go back and find it. Point is, there's big money behind saturated fats too. And there was big money behind trans fats. Trans fats are created in the old school processes by which they converted liquid seed oils into solid butter and lard replacements, margarine and shortening. There were lots of people who got very rich by convincing everyone that products containing trans fat were better for them than animal fats full of dietary cholesterol. But as we discussed on last week's pod, scientists figured out that the body makes cholesterol, whether you eat cholesterol or not, and trans fats are way worse for you than probably any kind of common dietary fat. The science happened, even though the margarine industry no doubt tried to stop it. But science won. Truth won. And now, artificial trans fats are all but illegal in the United States and the EU and tons of other countries. Natural trans fats still exist, and nobody can outlaw those because, beef has some trans fat in it naturally. And some products may still contain very small amounts of artificial trans fat, but even that is being reined in by the regulatory state. Even though the industry used to say, man, there's no way that we could make margarine and shortening and nonstick spray without trans fat. We need trans fat. Well, they found ways of making it without trans fat. Science won, in spite of the money. So I have faith in science to win here in the fullness of time. Maybe the fullness of time will show that Dr. Lawrence and the anti-seed oil crowd were right all along. Might turn out that they were right all along. But I doubt it. More importantly, I doubt that TikTok will be the first place I hear about it. This is high-level science shit that will not be adjudicated by wellness influencers, or even in the pages of books by scholars written for a general audience. If it really turns out that seed oils are the worst, if that assertion has been proven to the point where you, a normal person, should believe it and act upon it, you're not going to get that news from somebody like Dr. Kate. Dr. Kate Shanahan is, as far as I can tell, an actual doctor. Her website and social channels and books are the basis of so many social media claims about why seed oils are the worst. Trace the claim. There's a good chance it goes back to Dr. Kate. She brands herself as Dr. Kate, by the way. I'm not trying to disrespect her by using her first name. She goes by her first name. Dr. Kate is just one doctor. And her business appears to be mostly in persuading you and me, the general public, that seed oils are the main source of our problems. Ask yourself why she spends more time and effort trying to convince us than trying to convince other physicians and scientists. Maybe it's because she can't convince them. But she can convince us, and there's more money in convincing us. And maybe she sincerely believes everything she preaches, and maybe it'll turn out she was right. But when and if the assertion that seed oils are the worst is proven, to the point where you and I should believe it and act upon it, we're not going to get the news from someone like Dr. Kate. We're not going to get it from one expert standing alone out on a branch. And maybe she's got a few other experts out there with her on the branch, but almost all the other experts are back on the tree trunk. For right now, you and I have no logical reason to believe Dr. Kate, and Dr. Lawrence instead of believing the overwhelming majority of scientific opinion. The only way you could have a logical reason to side with Dr. Kate and Dr. Lawrence over almost every other scientist is if you are a biochemist who is at the forefront of the research into this topic. Are you? No? Well, then you've not earned an opinion on this subject. And neither have I. I've not given you my opinion on the underlying scientific controversies here. I've given you my opinions on some peripheral issues, but not on the fundamental science. I've not earned an opinion on that science. Of the people who have, nearly all of them are on team replace some of your saturated fats with polyunsaturated fats. I have no good reason to question them, and probably neither do you. You can call that an appeals to authority fallacy all you want, but scientific authority is earned authority. It's not a perfect system, but it's a functional system. System that has yielded the most unbelievable advances in human well-being that anyone could ever imagine, beyond what anyone could ever imagine. People in science earn their positions of power and influence. They don't earn them entirely, but they earn them significantly by knowing stuff, by understanding how complex this shit is. That's how they got their authority. So yeah, I'll appeal to their authority. They fucking earned it. And you and I are not in a position to scrutinize claims in this arena on our own. We're just not. We're not equipped. You probably know a whole lot about some subject, right? You're probably an expert in at least one thing. Now imagine that somebody else in your field who has some real minority edgelord opinions about your field. Imagine me reading an article by that edgelord and then saying, well, I've done my research. There's a reason that less educated people are more often convinced by outlier opinions. The most important part of education, in my humble opinion, is to gaze into the well of knowledge and to appreciate its depth. Once you really see how deep that well goes, you know how little you know about most things. Once you've become a real expert in one thing, you know the extent to which you are not an expert in all the other things. You are out of your depth. What are we to do with the dietary fat controversy, such as it is? Those of us who are out of our depth, what are we to do with this? Well, I think a safe option is to go with the preponderance of scientific opinion. Another safe option is to hang out in the territory that overlaps between the warring parties. The majority that thinks polyunsaturated fats are good and the minority that thinks polyunsaturated fats are bad, they both agree about a few things. They agree that sugar is terrible. They agree that refined carbs are terrible. Whatever you do, don't replace any of the dietary fats in your life with sugar and white flour products. Replace them with whole grains, complex carbs. Both sides agree on that. Both sides agree that monounsaturated fats are good, within reason. Olive oil and avocado oil. I use high quality extra virgin olive oil for basically all of my cooking because A, I can afford it, and I should acknowledge that not everyone can afford it. B, I think it tastes real good and it fits in most things. Pretty much the only thing that I use refined oils for is baking, making cakes that I don't want to taste like olives. And C, my C reason is everyone agrees that virgin or relatively unrefined olive oil is about as healthy as concentrated fat foods can get. Virgin olive oil it's full of antioxidants. It's not as vulnerable to oxidation in the first place because it's monounsaturated. It might not be as good as seed oils are at lowering cholesterol because olive oil has proportionally less polyunsaturated fat, But I figure I'm getting tons of seed oils from the restaurant foods and the processed foods that I do eat. So when I cook, I use olive oil. And if you don't like olive oil, try avocado oil. It's good in all the same ways. But in general, I'm still pretty sure that I eat too much fat, period. And too many carbs, period. And I am working on that. I wish you well as you work on yourself. Even if you are among those groups that I have certainly enraged with today's episode. If I got any facts wrong, let me know. AskAdamQuestions@gmail.com. That's where you can contribute questions or comments for this show. AskAdamQuestions@gmail.com. I am far more likely to actually use your question or comment in the show if you send me a video file, or failing that, an audio file. Introduce yourself, say your thing, ask your question, send me the file. I just talked for well over an hour about a very complex and controversial topic. And I'm sure that I got a bunch of little things a little wrong. But I'm pretty sure I got the broad strokes of it right. Sources are in the show notes. Check my work. Thanks for listening. Talk to you next week.